Hi and welcome, ladies and gentlemen. Today we are talking about how the internet works, especially what happens when you type in an address in your browser to surf in the internet. Alright, so let me start with a simple example. For that, imagine we have Bob and Bob wants to send a letter to Sarah, but unfortunately Bob doesn't know the address of Sarah anymore. So what he's doing, he goes to Alice and asks her, "Hey Alice, do you know Sarah's address?" And Alice responds and says, "Oh no, but I asked John, he might know what is Sarah's new address." So then Alice goes to John and asks him, and John says, "Yeah, sure, I know Sarah, I go and ask her." So he goes to Sarah, says, "Sarah, what's your address? Bob wants to send you a letter." So Sarah then responds with her address, and then John gives it to Alice back, and Alice gives the address to Bob. Alright, so now Bob knows Sarah's address. What he's doing now, he brings his letter to the post office. Well, from the post office, the letter will be delivered to a warehouse, a center where the post will be sorted. And from there, it usually goes to another warehouse closer to the destination of Sarah. So it will be delivered there, and from there it usually gets delivered to the house of Sarah. And then Sarah can go to her post box and pick up her letter. Alright, so when we are so far, the internet is connected similar like the people in our previous slides to the internet. So we have a network of devices. Well, the network of devices, the devices are the people which we had in our previous slides. So, and every device is somehow connected to the internet, as previously the people knew each other. But that happens in the case of the internet through the provider, which, you booked your internet where you have a plan. So, your router has a connection to the provider and receives a unique IP address from the provider. And with that, we have to talk a little bit about what an IP address is. In this case, I just want to talk about IP4 addresses. The new addresses are IP6 addresses. They just have a different representation. So there are more addresses overall possible. I have to say that every provider has a certain range of addresses it can hand out to each individual person, to each individual router in this case. So we receive an IP4 address from our provider. It is also called an internet service provider, which has a range of addresses. And we as a user, we don't have an influence on which IP address we receive from our provider. It simply gives us one. And it is built up by a block of, by 4 blocks of numbers between 0 and 255. So they're usually reserved IP addresses, like here the local reserved IP addresses start with 192.168, and the last 2 blocks we can use freely in our home network. For example, if we want to connect to our printer, or if we want to connect our phone or our notebook and so on, these will get an IP address from our router then. And that is usually a local IP address. So there's a little bit of a distinction between a local and a public IP address already. Because local IP addresses don't necessarily need to be unique, because, for example, your neighbor might have the same local network as you have. It also has 192.168.172.12 and can give this also to a printer or another device. Alright, and the public IP addresses are kind of similar. So these are unique. Here, for example, the Google IP address, which is here in this case, Google has obviously more than one IP address, but in this case I just wrote one down. It's the 216.158.223.9. Alright, so then we also have to talk a little bit about the architecture of the internet. When you type something in your browser is basically a client. And then we also have servers, and the server might be the server of Google, for example, that hands out the website in the end to you and responds on your requests. And then we don't usually type in the IP address of the actual server that we want to communicate with, that we want to get the website from. We usually type in a domain, and that is usually a text format like google.com. .com is in this case a top-level domain. It is just called like that. So the endings are usually like the top-level domain, and then we have a second-level domain, which is, for example, Google or Facebook. That are like the second-level domains. And we also have to remember that these second-level domains in combination with the top-level domains are also unique. You can book them, and then you basically own them until you don't want to extend your plan, and then they will be free for others again. One such example is google.com. Alright, so what happens if we type in google.com in our browser? So at first we say, or our computer is connected to the router and says to the router, because that is the only IP address it knows, hey, get me google.com. Okay, and the router says then, okay, I'm connected to the internet service provider. Let's ask the internet service provider, our provider where we have the plan, just to remember you, where is google.com? And the internet service provider has it either catched or has to ask someone, hey, where is the ending, the top level domain? I want to know, basically, who can you tell me where the Google is? So we start at the end with the .com, because in the end there will be also another named server knowing where Google is, but so we have to find that. So we ask the name server, and the name server goes then to another internet service provider, but this time the one where Google actually sits, and says, hey, where is Google? And so the internet service provider now knows which IP address Google has. The same as our internet service provider knows what IP address we have, because it gave it to us. So there we have the server of google.com, and the internet service provider can ask now back, okay, the internet address is here in this case 216.58.223.9. Alright, and then this will be propagated backwards to our internet service provider and to our router. And now we are at the same position as previously. We know now the address of Google. So that what we did right now is also called the domain name resolution. We want to get the address for a name. The same as we asked for the address earlier on in the example when we asked Alice and Bob for the address of Sarah. So now we can establish a connection between the server and our router or our client. Well, there we also have to be a little bit careful. That is not just a simple connection. It is actually a route as we had it earlier. So that is basically also a network over multiple servers to go in the end to the server of, in this case, google.com. So we could compare that to sending the actual letter. Alright, so there we establish a connection, and with this connection we can now ask, hey, we want the website, and the server then sends us the website to our router, and our router gives it back to the client, which is the browser, and then we can exchange the website data, for example pictures and the HTML and stuff. Alright, if we have a look at the route, it is similar as with the post, then in the end it is a routing table. As I already said, that is similar if we want to drive to certain destinations. We have certain points that we meet while we are on our journey. That could be crossroads, for example, when we want to switch the motorway. Alright, so here we have, for example, that is our home address. Then we go to our internet service provider, and then we have certain servers in between where we go through until we finally come to the internet service provider of Google, which then delegates the request to the server of google.com, and then we go the same way back. Alright, and after the connection is established, we can actually transfer the data between the server and our browser, our client. And that is usually done with certain protocols, for example HTTP or HTTPS. Earlier in the version 1, now in the version 2, it already exists a few years. I'm not completely sure, I think that since 2015. But there we see that the internet isn't the quickest in adapting to those changes, because around 50% are still relying on websites are still relying on HTTP1, and we have now HTTP2. Or here SMTP for sending emails, which works exactly the same way, it's just a different protocol sending it, or the file transfer protocol, FTP, SSH, and so on and so on. They all have their certain purpose, but usually when we just communicate through our web server, we usually use HTTP. And there, maybe you heard about that, is the OSI model, which goes through certain layers, also hardware layers and software layers in the end. And there are also different protocols implemented. And that regulates the OSI model. Also how the data is transferred over the line in the end on the certain physical lines, like glass, fiber, or copper lines, and so on. Well, anyway, let's come back. We want to transfer the data, and that is usually done through a request. We ask the server, hey, give me this website, and it returns the HTML and CSS and certain links, and then you say, okay, I want the image for that, and then the server sends the image and so on. And this is done between the web server and the browser. Alright, if you liked this video, give it a thumbs up and subscribe to the channel if it was helpful and if it helped your understanding how the actual connection works. So that's it for me. Have a great day. Bye.